And now we study the inverse trigonometric functions. Now, if we are told that a trigonometric function of an unknown value evaluates 2x, where x is some number, can we determine what the angle is? Technically, we cannot. We can list possible angles, but without knowing further information, it is impossible to know exactly which angle is being referred to. If, however, we are given certain other information, such as the quadrant that the angle is being located in, then it is possible to determine the exact angle that is being referred to. We now define the inverses of the 6 trigonometric functions we have introduced in a previous video. There is a slight problem in doing this. Recall that an inverse function exists if and only if the function is one-to-one. However, as we saw, the trigonometric functions are not one-to-one. We can, however, force the trigonometric functions to be one-to-one by making certain restrictions on their respective domains. The following slide is going to show the trigonometric functions with the restricted domains, which force them to be one-to-one. And here they are. So I will leave this screen up for a few seconds. If you need to, go ahead and pause the video to copy this down, and then resume when you are ready. Now, this slide shows the inverse trigonometric functions, along with the respective domains and respective ranges. Again, I will leave this slide up for a few seconds. Go ahead and pause the video if you need more time to copy them down, then resume when you're ready to move on. So we are asked to evaluate each of the following. So for A, the inverse sine of 1/2. So another way of asking this is the sine of what angle is 1/2? All right, remember, inverse sine has a range of minus pi over 2 to pi over 2. All right, so 1/2 is quadrant 1. Sine of pi over 6 is a half. So the inverse sine of 1/2 is pi over 6. The inverse sine of negative root 2 over 2. So the sine of what angle is root 2 over, or negative root 2 over 2 rather? Well, it's in quadrant 4, and it has to be between negative pi over 2 and pi over 2. So this is negative pi over 4. The inverse cosine of negative root 3 over 2. Alright, so the range of the inverse cosine is from 0 to pi. So negative root 3 over 2 would be in quadrant 2. And this would be 5 pi over 6. So the cosine of what angle is negative root 3 over 2 of what quadrant? 2 angle I should specify is negative root 3 over 2. That is 5 pi over 6. And finally, the inverse tangent of 1. So tangent of what angle is 1? So the range of the inverse tangent is minus pi over 2 to pi over 2. This is then a quadrant 1 angle. This is another way of asking what angle is sine and cosine equal. Well, that angle is pi over 4. So in the next video, right after this one, I will show you how to evaluate inverse trigonometric functions using technology, specifically using the TI Inspire. All right, so let's go ahead and evaluate the sine of the inverse cosine of 4/5. So to do this, we're going to make use of right triangle trigonometry. We say, okay, let theta be the inverse cosine of 4/5. Because remember, the inverse trigonometric functions will give you an angle. Now, if we go ahead and draw our right triangle, we can label this angle as theta. It doesn't matter whether we label this one or this one. So cosine, remember, is adjacent over hypotenuse. So this length would have to be 4, this length would have to be 5. Then this missing length here is the square root of 5 squared minus 4 squared. That is the square root of 9, which is 3. We can now find sine of theta. Remember, sine of theta is opposite over hypotenuse. So sine of theta, which is the sine of the inverse cosine of 4/5, is equal to 3/5. Now we're asked to evaluate the sine of the inverse tangent. Again, we're going to use right triangle trigonometry. So our angle is the inverse tangent of 7/4. Take this to be our angle here. So tangent was opposite over adjacent. So our missing side, the hypotenuse, is the square root of 16 plus 49. And that is the square root of 65. We can now find the sine of theta as opposite over hypotenuse. Sine of theta is the sine of the inverse tangent of 7/4. And this gives us 7 over the square root of 65. Finally, we wish to evaluate the cosine of the inverse sine of x over 3, where x is in the domain -3 to 3. Even though x is a variable, we are still able to use right triangle trigonometry to figure this out. So we let theta be the inverse sine of x over 3. We draw our right triangle as before's. So there's theta. So sine is opposite over hypotenuse. So our missing length will be the square root of 9 minus x squared. Then the cosine of theta, which is adjacent of hypotenuse, is the cosine of the inverse sine of x over 3, and we get the square root of 9 minus x squared over 3. Alright, and that is all there is to inverse trigonometric functions. Like I said, the next video after this one will show you how to use technology to evaluate the inverse trigonometric functions.